Hello pre-calc honor students, here we are with Venn diagrams, a good way to count sets. Now the universal set is usually represented by a big rectangle. This is all the possible things that can happen in the way that you're trying to count them. And sometimes we'll label that inside with a U. Here sets A and B, individual sets we usually use letters on. And you can either put the letter inside, or sometimes people label it right on there, or sometimes people put it outside like that. So the intersection of A and B is denoted like this, A and B. And it's those things that will make both sets true. So it's got to be the members that are in both sets, not in either set, the ones in both. So we're going to shade in the overlap here like this. That's how we represent A intersection B. On the other hand, A union B is when we unite both sets and include anything in either set. So that's what we end up filling in. There you go. Here's our notation for that. A UB for union, also known as A or B, whereas notice this was A and B. The complement of A means those things not in A. It's denoted by A complement with a bar over like that. And that means everything outside of A. So everything that's in the universe of possibilities, but not in A. So that's all this stuff out here. That's the complement of A. The complement of A and B, though, is a little trickier. And so for that, we denote like this, A intersection B, and put a complement symbol over the whole thing. Now, what does that mean then? Well, we look at A and B first, so that's the stuff inside, and take the complement of that. So that would be all this stuff outside the intersection of A and B. And that's the complement of A and B. Now notice that's not the same as neither A nor B, because that would be the stuff just outside both sets. So you got to be careful when you take a complement of a union, and there's something called De Morgan's laws that helps us with this. But basically, we can compare it to these two other choices here. If we look at the complement of A and the complement of B, and that's denoted as the complement of A intersected with the complement of B. Remember, this is the complement of A over here. Okay? Complement of B would be like that. If I intersect those two, I would get this stuff on the outside. Notice here now, the complement of A or the complement of B, denoted by complement of A union complement of B. Now look at the complement of A, that's all this, and imagine the complement of B. And if you unite them and take either one in either set, then you get this. Because here's the complement of B, right? So if it's an OR statement, it's going to include everything in that. That's the complement of B. And then the complement of A is everything outside of A, so that's going to finish off with this stuff. And so notice how these two were a match. And it's something called De Morgan's laws, that when you knot things like that, let me just give you a quick page on that, called De Morgan's laws. This will come up more again in stats, that the complement of A and B is equal to the complement of A union the complement of B. And similarly, the complement of A union B will be the complement of A and the complement of B. So you got to be careful when you're dealing with this set notation and so forth. It's not as intuitively obvious as you might think. Now here's the inclusion-exclusion principle, and that is for any sets A and B, the number of sets in the union of A and B, the number of elements in the union of A and B, is the number of elements in A plus the number of elements in B minus the overlap. Because if we look at all the elements in A and count those up and get this yellow area and add that all up, and now if we look at B and add up all those, notice this was counted twice. This area in here this was counted twice. So that's why you have to subtract it off once when you're trying to count how many people are in the union. So let's look at our first example here. I've got a Venn diagram to go with it. Of the 540 seniors at Central High, so that's the entire universe, 335 are taking math, 287 are taking science, and 220 are taking both math and science. How many students are taking neither math nor science? Neither math nor science, so that's going to be the students out here. So this is all the seniors. This is all 540 seniors. And M is going to stand for the 335 math students. And S is going to stand for the 287 science. So to figure out what's on the outside here, we can kind of keep working our way backwards here. Now notice I've put the M here. Sometimes that can be a little misleading because you might think that just this crescent shape is this part of M. So I'm just going to put it up here, put S over here like this, just so you know M represents the whole thing inside the circle. Because we can start actually with this intersection. 220 are taking both math and science. So we can use that statement right here in this little section in here. Now you've got the M area here, which is 335. So M is 335, but these are the people taking both math, and, these are taking math or math and science. If we subtract off the overlap, we get 115. So I'm going to put 115 in this section. Similarly, I can do the same thing with science. Science is 287. If we subtract off the overlap of 220, we get just 67. So 67 in this section. And now you can see what we've got here all together then. Math or science is, also known as math or science, is going to be the 115 plus the 220 plus the 67, and that adds up to 335 plus 67, or 502. 502. Now we say, well, the whole set was 540. So we take 540, because we're asking now how many students are taking neither math nor science. So that that's that outer area in here. So let's take the 540 and subtract off 502, if I add that up correctly. Oh no, there's only 402, I'm sorry. So 540 minus 402 is equal to U minus the 402, and we get 138. And that checks with our answer. Now another way you could have done this with our inclusion-exclusion principles is to say M or S will equal the number of elements in M plus the number of elements in S minus the number of elements in M intersected S. So that was 335 math students, 287 science students, minus the 220 overlap. So there's your 500, 622 minus 220 is your 402 that we came up with over here. Take your pick about which way you find works better. Now our next problem, in a survey, 113 business executives were asked what they read, and here are the results. Let's start putting these into our Venn diagram. How many read none of the three publications? So let's find out here. So we can start filling in some things in here. Let's see if I can't pull this. Oh, can't pull the whole thing up yet. Okay. So 113 altogether, but let's start with this in the very middle here. 42 read all three. That's really going to help. Starting with this, the triple overlap there. There's the 42 in the middle there. And then 6 only read the journal, so we can fill in this space here with a 6. And 5 only read Business Week, and 8 only read Time. Okay. Now 88 read the journal. Now you can see what we've got going on here. The journal is this whole area, but there were still 2 unknown areas in here. So if we just call this X, Y, and Z, we can maybe set up a system of equations involving these. Because then the journal, this 88 read the journal would mean 6 plus 42 plus X plus Y would equal 88. And 76 read Business Week. So let's look at Business Week. So that's 42 plus 5 plus X plus Z equals 76. And 85 read Time. So that's 42 plus 8 plus Y plus Z equals 42. So that time equation simplifies down to Y plus Z equals negative 8. And the journal equation simplifies down to X plus Y equals, this is 48, so X plus Y equals 40. And the Business Week equation simplifies down to X plus Z equals, well, we got 47 here. X plus Z equals 76 minus 42 would be 34, I think 29. 29. So now we have 3 equations and 3 unknowns. X plus Y equals 40. X plus Z equals 29. And Y plus Z equals negative 8. What we can do is maybe just subtract these 2 equations to produce Y minus Z equals 40 minus 29 is 11. And then put these 2 together. Y plus Z equals negative 8 to get 2Y equals 3. And that doesn't work out. Let me check some of my arithmetic. Found the mistake. It's right here. I copied the 42 from here, but time was 85. So these add up to 85. So that means the time equation, which was Y plus Z, Y plus Z will equal, this is 50, subtract it equals 35. There we go. Y plus Z equals 35. So, finishing our system here then. Let's get that filled in. So 2Y equals 46, so Y equals 23. Okay? Then we can go on to find out the other ones then. That means 23 plus Z equals 35. So Z equals 12. And then finally we can figure out X. Because X plus Z, which is 12, equals 29. So X equals 17. So we've got all our missing bits now. We can plug those in, and when you add up those 7 numbers, that's 6 plus x, which is 17, plus 5, plus 42, plus y, which is 23, plus z, which is 12, plus 8. Let's see what we get on that one. And we add them all up, and you get 113, which is odd because that was our total number of businessmen, our business executives. So that means there are no business executives that read none of the magazines. Sometimes represented by our Greek symbol here. The empty set. That's the empty set symbol. Okay, flange out.